With temperatures rising, you may find yourself hot and bothered. But a new technique may be able to help cool you down by automatically pulling sweat away from the body and releasing it as water vapor. An unusual material has been discovered which uses water halfway before it becomes fully saturated with water. The finding came as a surprise to the researchers from the Department of Energy's Pacific Northwest National Laboratory, who accidentally created the material when an experiment did not go as planned. One of the researchers was inspecting a solid, carbon-rich nanorod with a vapor analysis instrument when he noticed the nanorods mysteriously lost weight as humidity increased. This was very unusual, and so they assumed the instrument had malfunctioned. However, when they looked at what was happening using a microscope, they saw an unknown fluid unexpectedly appear between bunches of the tiny sticks and ooze out. It seemed that immediately after expelling the fluid, the nanorod's weight decreased by about half, a phenomenon that had never before been seen. Dr. David Lau, who made the discovery, said, "Our unusual material behaves a bit like a sponge, it wrings itself out halfway before it's fully saturated with water." A paper published in Nature Nanotechnology describes the physical processes behind this spectacle, which turned out to be the first experimental viewing of a phenomenon theorized 20 years ago. The discovery could lead to a large range of real-world applications, including low-energy water harvesting and purification for the developing world, and fabric that automatically pulls sweat away from the body and releases it as a vapor. Mr. David Hildebrandt, one of the authors, said, "Now that we've gotten over the initial shock of this unforeseen behavior, we're imagining the many ways it could be harnessed to improve the quality of our lives." This discovery comes off the back of a theory which was first proposed in the 1990s by scientists studying crystallized proteins. Back then, scientists noticed they only saw water vapor surrounding hydrophobic sections, those that repel water, of the protein, while liquid water would surround other areas. The researchers proposed that there was some sort of process that enabled the water caught between hydrophobic protein sections to suddenly vaporize. Using this knowledge, the researchers in this study suggest that water was condensing and forming a bridge between the nanorods, through a process known as capillary condensation. They believe water between rods forms a curved cavity whose surface tension pulls the adjacent rods closer together. When two intersecting nanorods get close enough, the water caught between them could be forced to quickly evaporate. The real-world applications for this technology could make huge improvements to quality of life. Large quantities of the material could repeatedly take on and then eject collected water when a certain humidity level is reached. Such a system could be used in remote deserts, where it would collect water from the air and harvest it for human consumption. Another use could be in clothing fabrics, which would enable more comfortable outdoor activities, by removing sweat from inside the clothing and emitting it as water vapor. The researchers hope to now scale up their production of the material to make these real-world applications viable. However, Satish Noon, one of the study's authors, said, "Before we can put these nanorods to good use, we need to be able to control and perfect their size and shape.